Hi, I am Karthik Rannan. I am the president of the Wall Street Club of BITS Pilani Hyderabad campus. Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives while they try to navigate the world of finance. I am happy that we will be able to close this workshop successfully on a very good note.
Hi, I am Raghunendra Singh and I am the Technical Director of the Wall Street Club at BITS Pilani Hyderabad campus. It was a great amazing conducting this workshop with XLR. The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets, which was very helpful for the people who are interested in the field of finance, business or analytics in general. Thank you.
I attended a workshop conducted by CSA and ACM in collaboration with XLR. So it was a machine learning workshop. We learned a lot from the course, and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching, and it was fabulous.
This was a great experience for me, so I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
The journey was great. Initially, I thought that I was not proficient enough in Excel, but later I came to know there was no prerequisites for it, and then I applied for it, and it was a great course, and it started from basics and took me to a great extent.
Good evening, myself Kavya Ganatra. I am from Computer Science Association. I was the POC for this ML workshop conducted by CSI and ACM in collaboration with XLR. The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our Technical Fest Atmos, and I thank XLR for being a part of it. Thank you.
Yeah, hello everyone. My name is Tasneem. I'm the senior manager at 98 percentile in the HR department. And today we did a wonderful drive with XLR. It was amazing right from the very beginning, from the very first day when I got in touch with them till today. I think it was an extremely smooth journey with them. There were multiple follow-ups done by the representatives in order to check that we would be, what time we would be coming, how many people would be coming, what vehicle we would get. To that extent, they were so precise in giving all the information to us. It was extremely great to get associated with them and have a drive at XLR campus. So we are very, very happy that we got a chance to do this. Now, coming to the students, what XLR had, I think they were extremely enthusiastic. They were well prepared. They were aware of what they are coming for. I think there was some back-end preparation which they did that was commendable. They also were very confident and they were open to any kind of thing we were asking them to do. That was I think the best part. Now, I really hope we have a very, very fruitful association with each one of them and XLR in future. We are really looking forward to have many more drives like this.
my name is Prachi Sharma and I'm the Senior Project Manager for IT Department at 90th Percentile. So today we were here for this IT bootcamp, right, this technical drive and at XLR. So it was a great experience and I would feel that the students, they are the freshers, right, but it doesn't seem like that. So if I talk about their technical and cognitive ability, they all seems pretty good in that, and that's what I felt. And I guess they have been taught pretty well at XLR, so that's how they have performed good in their aptitude and the technical tests. So I wish them very all the best, and it was a very great experience over here.
Hi, this is Patan, Technology Consulting Manager from 98th Percentile. We visited XLR for the campus placement drive and it went very well today. Miss Ambika, Miss Pragati, everyone received us greatly here and we had a lot of enjoyable time here. The students even had great experience with us. They were interactive, they had good aptitude and all the technological skills they showed. I think they were all well and we really appreciate their time that they spared to us and I think we will be doing a great job. We are expecting a lot of people to be hired from them. Let's see. It was a great experience altogether.
Thank you.
Thank you so much.
From entering into this cyber tower to exiting out of this tower, the XLR team has been received me with such a care and pleasure.
I am the part of this XLR since 4 months. From the third month itself, they have conducted the placement sessions from the third month itself, and this is the fourth month, and this is the 90th percentile is one of the placement drive I have attended so far, and attending to this drive is such a good experience for me. All the HRs and the team made us feel very comfortable and confident.
XLR helped me a lot and I experienced a lot of things today. So I'm really hope to be placed in that company. I'm confident about that. Thank you.
Am I audible to all of you guys? Yes or no? Okay, cool. So, yeah, I'm audible, right? Yeah. So let me share my screen, guys. Uh, is it visible to all of you guys? This PPT? Great. So let's start the session. Cool. Okay, guys. So let's start with the session. So in past two sessions, guys, we saw how to handle the numerical data, and we also saw what are the basic data structures in the Python, so that we can understand how we are getting the output, how the data is being stored, right? And in the last session, we saw how we can handle a numerical data, what are the different methods, and how you can interpret the result. Okay, so with that introduction, let me start the main topic of this particular program, that is the NLP, which stands for the Natural Language Processing. Right? In short, it is called as a NLP. It is also called as a text analytics. Text analytics. Right? Sometimes it is also called as a text mining. Right? So these are the different terms based upon which kind of operation you guys are performing. Ultimately, all of these are part of the NLP only. That is a natural language processing. Right? Now, this natural language processing is one of the application of the data science domain. So data science in itself is a big umbrella term. So let's say here we have a data science part, data science, and within that we have a one of the application of data science as the NLP. Like that, we have a different applications of the data science. So one of the application we are dealing today is basically that is the NLP part, right? Okay. So before starting with the introduction part of the NLP, I want to know from you guys, what do you understand from the term NLP? Or it is first time you guys are listening this term? So anyone who knows what is the NLP, or it's a very new term for you guys? Okay, not an issue. Trying to understand the image processing. Anila, okay, not actually. Anyone else? Image recognition, okay. After this something, okay. So, okay, let me use, okay, first time, okay. Understanding sentiments, great, Nandini, okay. Getting insights from the text, okay, that's cool. Viprajit, okay, great, guys. So let me first clear you, because, a couple of you guys are thinking about we are going to deal with the image processing. So that's not correct. So NLP is a domain which totally deals with the text data. Text data, right? So whatever data we handled or we do some manipulation in yesterday's session, that was the numerical data. Now, if we are getting some text data, so what is the text data? Let's say the tweets data from the Twitter, right? Or let's say you buy a product from Amazon or Flipkart or any of the e-commerce website, and after utilizing the product, let's say after 2 days or 3 days, after 7 days, you write some reviews, right? So those reviews will get collected, and if you're getting a data for those reviews, that is a text data. So you write the review like whether the product was working well, or the the worst product or the good product, something like that. Or let's suppose you watch the movie over some of the platform, let's say Netflix, and then after watching the movie or series, you provide some feedback if you want. So that is also a text data, right? So how we can deal with this kind of a text data, that is something we are going to understand from the NLP part, right? So NLP is a domain of data science that will completely deals with the text data analysis perspective. Okay, so here we are not going to deal with the image part. So let me just extend this particular discussion. So if you want to analyze the images or videos, for that we have a different domain in the data science, that is something called as a computer vision. Computer vision. So that is the domain in the data science which completely deals with the images or videos, right? So how you analyze the images, or how you analyze the videos, or what kind of modeling will be there with respect to images or videos. So all of those things comes under the computer vision section. But since we are dealing with the NLP part, so since NLP deals with the text data only, so that's why whatever things we are going to discuss from now, that will be with respect to the text data only. Right? Is that clear, guys? Yes, so chatbot is one of the application of NLP. Yeah. Okay, so I hope a basic introduction is clear to you guys. What is the NLP and what we are going to do here? Yeah, well, let me repeat it once again. So for that, let me just come to this slide. So here it is written, guys. What is the text mining or NLP? So basically, we use these terms, interchangeably. So don't get confused when I use the term text analytics or text mining or NLP, right? So more or less, these are same. So basically, what we do, we apply some kind of a methods or techniques. Why we apply the techniques? To extract some hidden information from our text data. So NLP is the domain of data science where we analyze the text data. Text data. So to analyze this text data, we apply some kind of a statistical techniques or modeling. Through that, we can get some hidden information from our text data, right? So this is something we call as a NLP, or text mining or text analytics. Now, throughout this course, we are going to understand what are the different techniques or methods are there, how we can apply those techniques, and how you can interpret the outcome. And before applying the techniques, what are some pre-processing steps, since you are dealing with the text data, not the numerical data. All right. So all of those things we are going to understand. Okay. Cool. So let me just show you what are the applications of the NLP in the real-time perspective when it comes to the real-time part. So what are the different applications we guys are using as a organization? So there are a lot of applications, like we have something called as a document classification. What is this document classification? So basically, let's say you have a different documents for an organization. So let's say this is a document one. Let's say document one. We have another document, document two. This is another document, document three. So document is nothing but, let's say, what we have. It's a simple text data where we have some text information. Let's say some article or document, or let's say some research paper. This kind of things. So let's say likewise, we have a multiple documents present for an organization, document N. And we want to classify these documents. For example, let's say a couple of documents out of these N documents, couple of documents belongs to, let's say, sports domain. That means the documents which contains the information related to sports. There will be few documents that contains the information related to some science topic. Right? There will be few documents which will contain the information related to some economic part. right? So likewise, we have a different documents from different you can say domains. So document classification is nothing but we will apply certain kind of a techniques or methods so that we can classify each and every document, whether this document belongs to sports domain or science or economy or any other domain. So based upon the content present in this particular document, the technique will classify the document in which particular class or category the document belongs to. That is something called as a document classification. Right? And we have another very interesting application of the NLP that is called as a document summarization, which is nothing but, let's say you have a research paper. You have a research paper which is of let's suppose 20 pages. You have a 20-page research paper with you, and you don't want to read the research paper line by line, right? So what we can do, we have an application of NLP that is called as a document summarization. We can apply certain techniques to these documents so that the technique will give you a simple 1 or 2 paragraph summary for this particular research paper. So just by reading the summary, I can get an overview idea what is the content present in this particular research paper. Right? You can summarize your text information. For example, let's say you have a very long article. Let's say you have an article of, let's suppose, 500 lines. I don't want to read all these 500 lines. I want to know the gist of this particular article. So what I can do, I can use certain kind of a techniques that will provide me the summary of this article in a very short. Right? So that is something called as a document summarization. Okay. And then sometimes we use the concept of NLP in the recommender system. So what is a recommender system? Recommender system is nothing but, so it's like we recommend you the same product or same kind of a product based upon your past behavior. For example, if you guys purchase any of the product over the Amazon or let's say Flipkart, so next time when you log in with your account, you will get recommendation for the same kind of a product. That is something called the recommender system. So based upon your past purchase or past behavior, the system will recommend you similar kind of a products. That is something we can apply in the NLP segment also. So let's say a particular person watched some kind of a movie, and after the movie, the person provide the feedbacks or review. So just by analyzing the feedback, we can recommend what kind of a movie that particular customer likes. Right? So that is something called as a recommender system. Let's see another some more applications of this NLP part. So we all we guys know the virtual assistant systems like Alexa, Siri, Cortana, right? So they all works over the, they take the signals as a speech or voice and they convert into a text signal, and then they perform the operations. Whatever chatbots we have, so all those chatbots, what they will do? So let's say this is a chatbot. So what chatbot will do? We provide our input query in the chatbot, like here. And the input query is a text information, right? So we like in a text data kind of thing, whatever we input query we have. And this text input query will get into the chatbot. And the chatbot, whatever technique is being used at the backend, based upon that, it will generate the outcome for your input query. And the outcome is also a text data. Right? Can we rely on the data which we get after summarization? Yes, Madhu, you can. Right? So we have built the models based upon some, very nice algos, nice techniques, right? They have a very good accuracy. So that is something. We have another application like chatbots. Then another very popular application of NLP is a sentiment analysis. That is also called as a emotion mining, which is something but just to identify the emotion of the customers, right? Let's say you went to a hotel and there you have some, lunch or dinner, whatever you had. And after that, you provide the feedback, whether the food was good or, it was yummy or it was not good, the worst service, something like that. So based upon your reviews or feedback, we apply certain kind of, techniques to identify or extract the emotions from that feedback, so that we can understand whether the customer was happy or customer was not happy or the customer was neutral, right? Even we can also identify if the customer was happy, up to what extent the customer was happy, right? So all of those things we can do under the sentiment analysis, right? And then we have another application as a translator. So actually it is called as a machine translator. Machine translation or machine translator is another application of the NLP. What it does, so basically, let's say this is the machine translator technique, what we have, this box, machine translator, or let's say translation. So what this machine translation will do, if you provide your input data, which is a text data, input text data in one language, let's say this input text data in a French language, this machine translation will convert this input text data, which is in French language, into an output text data in some other language. Let's say I want to translate this particular text data from French to English. So I will get the output text data in English language. That is something called as a machine translation. Translating your input text data from one language to another language. Right? This is another popular use case of the NLP. And then document similarity is another useful case. So document similarity is nothing but, let's say you have a multiple documents and you want to identify what are the documents which are very much similar to each other. So that similarity means that you can also analyze. So, to accomplish all of these, tasks, we have a different techniques, different approaches are there. So based upon your data set, we can adopt any one of the approach to accomplish these tasks. Is that clear, guys? What is the NLP? What are the applications of the NLP and so on? Any doubt, anyone? To understand what is this particular term called NLP. Let me also check with YouTube, guys. Okay, cool, great. So this is what we have discussed, things like let me just do one thing. I had a new slide. Okay. Okay, guys. So this is what we have discussed, something called as a what is the NLP and what are the use cases of NLP. Now, guys, let me just check one thing. Okay. Now, guys, if you recall the yesterday's session where we deal with the numerical data, so whatever, technique or statistical methods or models we have in the data science domain, all of those models or techniques will be applicable over numerical data only, right? You can't apply any of the statistical method or, any of the numerical technique over the text data directly. So let me just show you how we actually approach over the text data and what are the steps involved, to handle the text data and when it comes to the apply certain kind of a techniques. So this is something I'm calling it as a NLP pipeline. NLP pipeline. So that means what are the approaches, or you can say what is the sequence how we proceed with the text data. So let's say you got a Amazon review data for different Amazon products. Then how would you approach? How would you start with this data? So this is something I'm going to discuss. So I'm calling it as an NLP pipeline. So let's say this is the input data what you have from some source, which is a text data. So it's an input text data, right? Now, once you get that input text data, so actually we can't apply directly any of the statistical technique or methods or model over this input text data. So what we do, we first observe this data, and sometimes what happens, guys, there will be some abnormalities will be there in the text data, right? Now to remove those abnormalities, what we do certain kind of a cleaning, or it is called as a text data pre-processing. So once you get the input text data, first of all, what we do something called as a text data pre-processing. Text data pre-processing. Right? It is also called as a text data cleaning. So what is this text data cleaning? So sometimes there will be some abnormalities present in your input text data. Now, what are the abnormalities, and how to do that part? That is something I will come after some time, right? I will discuss this part. But let's first see what is the NLP pipeline. What are the steps? How would you approach? Now, when you apply the text data pre-processing steps, so under that we have a multiple things are there. Now, after applying the text data pre-processing, here this is the place what we will get. We will get something called as a clean text data. Clean text data. That is the outcome of the text data pre-processing part. That means whatever text data I will get after text data pre-processing, in that data there won't be any abnormality, right? So that's why we are calling it as a clean text data. Now, over this clean text data, even although this clean text data is a text data only. So since it is a text data, even at this point of time, I can't apply any of the statistical technique or any of the model or any of the method, because whatever methods or techniques we have, that is only applicable over the numerical data. So here we do one more step, that is something called as a vectorization. So this step is called as a vectorization over the clean text data. Now what this vectorization will do, it will transform your clean text data into vector representation. So this vector representation is nothing but it is the numerical representation of your clean text data. So the output of the vectorization is basically you will get equivalent vector representation, which is the numerical representation actually. Representation of your clean text data. Right? So this is the outcome of your vectorization. So how to apply the vectorization, what are the different methods are there? This is something I will discuss in some time. But yeah, So over the clean text data, we apply something called as a vectorization. What this vectorization will do, it will transform your clean text data into its equivalent vector representation form or a numerical representation form. Now, this is the place how we get the numerical representation of our text data. And once we get the numerical representation, so this is the place where we apply the different statistical methods or techniques based upon your problem statement. Apply methods or techniques or whatever model you have. Model means it will be it may be a machine learning model or it may be a deep learning model. So all of those things I will discuss throughout this course, right? And then once you apply the model or technique, whatever model or technique you have, then you will get the outcome. That is the final outcome, right? So I mean, this is the NLP pipeline, what we are calling it, and how we approach any of the text data. Is that clear, guys? All of these, terminologies. Right? So, guys, I have explained a couple of times what is the NLP. So, NLP is nothing but it is a domain in a data science where we deal with the text data only. Right? How to handle the text data and how to apply a different kind of processings, or you can say technique over the text data. So that is the domain what we have something called as a NLP. Yes, Kritika, vectorization, like I will explain this thing, like one by one, each and every part. So for the time being, just understand vectorization is a technique which will convert your text data into the numerical form. For example, let's say here I have a word, let's say word I have a analysis. If I pass this analysis word, for example, like I'm taking just a random example. If I pass this word analysis to vectorization technique, so it will convert this analysis into some vector form. So let's say 20, 10, 2, 9. So this kind of a numerical representation will get created for your input text data. That is something we are calling as a vectorization. So this is just a simple example to understand, right? So vectorization is nothing but it will just convert your text data into its numerical equivalent representation. Okay. This approach is similar to machine learning project. Yes, Ankit, approach is very much similar to machine learning project, but here we have things related to the text data only, right? Okay. Any other questions, guys? Anyone? Everyone understood this NLP pipeline, how we approach? Cool. So if this part is clear, now let me come back to these boxes. Like what is the text data pre-processing? What is the vectorization? And what is this, techniques and models are there. So each and everything, right? What is domain? Where we have a domain, Yamuna? Okay. So let's first discuss, guys, the very first block, which is a text data pre-processing. Right? So let's start from this point. And then once we complete this particular block, then we come to vectorization part. Right? So let's see. Now, when it comes to the text data pre-processing, guys, just a minute. Yes, Akash, don't worry. I'll be dealing each and everything from the scratch only, right? Okay. So to give you an idea what is a text data pre-processing, let me share this particular part with you guys. Just a minute. So, okay. So this notebook is visible to all of you guys. Cool. Yeah. Okay. So let's see, guys. First of all, let me just show you how text data looks like, right? By the way, this notebook is present over your LMS portal. I guess in day 3, it is present. So if you want to, do the things parallelly, you can also do that. All right. Okay. Let me first show you guys how a text data looks like. See here. So this is the book data I have with me. And what this data contains? This data actually contains the feedback or the reviews from different customers for a Amazon product, right? So we have a different reviews from different customers for some Amazon products. And like here you are seeing, like it's not a complete review because of the size limit. So let me scroll it down and let me just show you a complete review. Yeah. So these reviews will look like this. Like this is the first review, what we have. This one is the second review. So likewise, we have a different reviews from different customers. Right? So like you can see, this is one of the review. This part is a one review. Even this is another review, right? So all of these reviews are present over this data set called book. So this is a reviews data set. Like that, in future, you might have some feedback data set, or let's say tweets. So it can be anything in a text form. So this is how our data looks like, right? Now to understand the NLP part, it is very much required to understand a couple of terminologies with respect to your data set. Okay. So let's see what is the terminology and all. So guys, whatever reviews we have in this case, that means whatever, reviews or feedback from the customer we have in this data set, each and every review is called as a one document. Right? Each and every review is one document. That means the first review is one document, second review is another document, third review is another document. Likewise, each and every review is one document. Okay. Now, can you guys tell me what is this number 01234 is showing? What is this particular number? Great. It's a indexes, right? So if you see here, guys, the index starts from 0 for this data set and it goes up to 39. So how many documents I have in this data set? 40. Great. Cool. Yes, guys. So each and every document, like each and every review is a one document. And in total, in this data set, we have a 40 documents. Right? Now, collection of all the documents. So like here we have a 40 documents. Collection of all the documents is called as the corpus. Right? So that means in this particular corpus, we have 40 documents. And what is the document? Each and every review or feedback is one document. And collection of all the documents is called as a corpus. Is that clear, guys? These terminologies? Okay, so this is one thing. So here I have written, guys. So like NLP is a branch of data science which deals with the text data, right? And what is a corpus? Collection of documents. And we have another term that is called as a corpora, which is a plural form of the corpus, but not very much, used this particular term. So not very frequently used this term. So most commonly you will find the terminologies as corpus or documents. So I'm sure everyone is clear what is a document and what is a corpus, right? Okay. So if you guys are clear what is a corpus, what is a document, let's come to our text data pre-processing block, which is the first block. So if you recall the NLP pipeline, we have an input text data, and then the second block is something called as a text data pre-processing. Text pre-processing, right? Now, why we use the text data pre-processing? Just to clean our input data. So we need to check whether there is any abnormality present in our data set or not. If yes, then we apply certain kind of methods to get rid of that particular abnormality so that my data will become clean. Now let's see what are the different things we do in the text data pre-processing. Since we are dealing with the text data, so sometimes, guys, you will get the punctuations. So here the meaning of the punctuation is basically getting the special symbols like dollar or brackets, star, percentage, at the rate, exclamatory sign, so like that, comma, like this kind of special characters. So if these things are present, so what we do generally, we remove these punctuations because these symbols are not contributing any information, right? So generally we remove these punctuations. Then sometimes you will get the URLs present in your corpus. So like www.thisone.com or www.xyg.com or .co.in, like that. So this URL is of no use, so we remove the URLs also. And then we apply another step that is called as a removal of the stop words. Now, what is this stop words? So guys, here I've written stop words are most commonly occurring words in the text that do not provide any valuable information. For example, like they, he, his, her, is, was, there, this, them. So these kind of words, which they occur most commonly across the document or corpus, and they are not contributing any valuable information. So these words called as stop words, and we remove these stop words from our text data, right? Then we can also do something called as we can convert each and every document into the lowercase so that there won't be any difference between a capital A and a small a, right? So that when we apply certain techniques or methods, so capital A and a small a will be the same, right? So let's say in one document we have a word called analytics, like this, and in another document we have a same word like this, analytics. So here we have a A in caps, here we have a A in small. So probably when you apply the technique, any of the statistical technique or method, so probably for this particular word you will get some different output, for this word you will get some different output, but actually the word is same. So to remove this kind of ambiguity, what we do, we convert our text data into the lowercase so that all of the words will be in lowercase, right? Up to this point, guys, things are clear. Any doubt or any queries up to this point? So these are the different steps what we do under the text data pre-processing. And it is not mandatory to apply all of the steps. It totally depends upon which kind of a text data you guys are dealing with. So let's suppose in your input text data, already we have all the words in a lowercase. Then no need to apply the lowercase part, right? So it totally depends upon which kind of data you guys are dealing with. Okay, do we need feature extraction here? Yes, feature extraction is there. How to decide? Okay, I will come back to all of these points, like how you can apply all these things. So for the time being, let's understand what are these things. Okay, conceptual wise. Then I will show you how you can apply each and every part. Okay, guys. Cool. So this is something we have removing the punctuations, removing the URLs, removing the stop words, lowercase converting, removing the stop words. Now, apart from that, we have a couple of more things, something called as a tokenization. So tokenization is nothing but that separates text into units such as a sentence or words. So this is nothing but, let me just show you from here. Guys, this PPT is visible, right? Arjit, yeah, actually we apply, so we have a different methods to apply and the method will take care of it, right? Okay, cool. So guys, tokenization is nothing but we break our sentence into the words and each and every word will be a one token. For example, let's suppose I have a sentence called as the capital of China is Beijing. And if I apply the tokenization, what tokenization will do? It will just, it will break this sentence into different words. Like the is one word, capital is another word, of is another word, China is another word, is another word, Beijing is another word. Each and every individual word is one token, right? This is something we call as a tokenization. Okay. Now, apart from tokenization, we have something called as so this is the stop word removal I have already covered. Okay. Apart from tokenization, we have two things, something called as a lemmatization and stemming. So let's understand what is a lemmatization and what is the stemming. These two are very similar, but let's understand. So let's see first stemming part. So stemming, what it will do? It will just chop off the end of the words. That means whatever suffix or prefix you have in the words, it will just remove those suffixes or prefixes. That is the stemming. For example, if you have a word called running, and if you apply the stemming over this particular word, apply stemming, what stemming will do? It will just remove the suffixes from your this word running, and what it will return? RU-double-N. What is left? RU-double-N. But this is not the actual word, right? The actual word is a run, or the base word is a run. But what stemming will do? It will just remove the suffixes. Let's see another example. Let's say you have a couple of words like argue, argued, argues, arguing. If you apply the stemming, what it will do? It will just remove here ing, from here it will remove es, ed, and here it will remove the e. So you will be left with argu. It is not the word. The actual word is a argue, gue, right? So this is something we call as a stemming, which will remove the suffixes or prefixes from your data set. Then, to overcome this particular drawback, we have something called as a lemmatization. What lemmatization will do? It will convert your tokens or words into its base form or the root form. So it will just convert your word or token into its root form or the base form. For example, argue, argued, argues, arguing. For all of these words, the base word or the root word is argue. Right? Similarly, if you have a ran, running, this kind of a word, so for both the word, the base word is a run. This is what lemmatization will do. So like this is the difference between stemming and lemmatization, right? Exactly, Arjit. Is that clear, guys? What is a stemming? What is a lemmatization? Don't worry, guys. All of these things we are going to see through hands-on also. Okay, cool. Let me also check with YouTube, guys. Guys, don't worry. As I told you, we are going to see all of these steps one by one through hands-on also. So for the timing, let's understand the concept first. Okay. Where we can use the stemming. Okay. So as I told you, what stemming will do, it will remove the suffixes. So sometimes what happen, you won't get the correct word. So that's why I explained you guys, instead of stemming, we actually go with the lemmatization, right? And where we can use it, so this is the data pre-processing steps. So let's say in your data, in your input data, we have a word called running. So what we'll do, we will convert this running word into the run, into its base form, right? For the further analysis. So that when we apply the vectorization, I will get the correct representation of that particular word. Yes, Nandini. So what we do, we apply the lemmatization rather than stemming, right? Psi stemming may give you the root word or may not give you the root word. So stemming would only remove the suffixes, and whatever is left, that is the output for stemming. It may be the root word or it may not be the root word. Just like in the case of running, right? Guys, this PPT and the code and dataset, all of these things are available over the LMS portal for day 3, I guess. Okay. Cool. So let me share my screen. Gaurav, this is what I explained you guys. So generally, we skip the stemming part. What we do, we apply the lemmatization only. Yes, Arjit, correct. Okay, so let me share my screen. Okay, I hope my screen is visible to all of you, right? Okay, cool. So you can see here I have also written a couple of more examples for stemming and lemmatization. So let's say you have a word called as a entitling and entitled. So if you pass these two words to stemming, what it will do, it will just remove the suffixes. And after removing the suffix like ing and ed, what we left? entitl. But this is not the correct word, right? The correct word is a entitle. This is what stemming will do. So stemming will just remove the suffixes, and whatever is left, that is the outcome. While in case of a lemmatization, it will convert the word into its root form or the base word. So if you have words like running, runs, ran, so for all of these words, the output will be run. Right? So this is another example for stemming and lemmatization. Now, let's do some hands-on and let's try to understand how we handle the text data. Right? But before that, any queries, guys? Anyone? Okay, great. So, yes, Arjit, correct. So, guys, yesterday we saw two libraries, Pandas and NumPy, right? So, and we understand that what is the role of library, and within the library, we have a different functions. Now, when it comes to the text data handling part or NLP, so there are a couple of important libraries are there to handle the text data. So one of the most important library which we commonly used for NLP related tasks is NLTK. It stands for the Natural Language Toolkit. Natural Language Toolkit, in short, NLTK library. Apart from that, we have something called as a Spacey. That is another library to handle the text data. Not only that, we have something called as a text blob. Text blob is another library which we can use, to handle the text data. Even we have one advanced library that is called as a Flare. Flare is another library that is used to handle the text data. Right? And this is not the end of this list. We have a couple of other libraries. But most commonly, we use NLTK to handle the text data. Okay. But in this course, so I will be covering NLTK, text blob, and Flare. Right? So throughout the course, I will be dealing with the things related to NLTK, text blob, and Flare. But for the time being, let's concentrate over this NLTK library. That is nothing but the Natural Language Toolkit. Okay. Okay, cool. So, okay. So see here, guys, to start with, first of all, you need to install these libraries and some other dependencies. Since in my system, it is already installed, so I'm not going to run this particular part, right? But what you guys need to do, you need to just remove these hash signs and then, run these cells so that whatever dependencies will be there, it will get installed. Okay. And then I'm just, importing couple of important libraries and all. And this is the CSV data what we have, which is the review data, or you can say feedback data for Amazon's product. And we have in total 40 different reviews from different customers for different products. All right. And we are just importing this data using the read_CSV method, since it is a CSV file. This file and the code is already there over the LMS portal. Okay. Cool. So let's see, guys, how we proceed. Okay. So here in this data, we have 40 documents, and this collection of all the 40 documents is called as the one corpus. So first of all, what we are going to do, we are just, combining all of this review inside one list, right? So this is what we are going to do. Like we are taking each and every review from this book data set, and then we are creating a list of documents, right? So this is what we are getting. So you can see here, this is the first review I have, comma. This is the second review up to this point, what we have. Then this is the third review. And if you just scroll it down, we have a couple more other reviews, right? So here I have just printed first 10 reviews. That's why we are seeing only these reviews, right? And then what we are doing, since in this list, each and every review is an individual review, so we are just joining each and every review to make it as a one single paragraph, right? So we are just joining each and every review based upon the space. What happened? Can you explain the syntax for the loop? Okay. Okay, Atul, if the material is not there, probably it will get uploaded by tomorrow, most probably. Right? So, guys, if you see, yes. So, if you see here, we have a strip method applied over each and every review. That means if there is any leading or trailing spaces is there in the review, it will get removed, right? And after removing any leading or trailing spaces, if there is any, then it will just combine each and every document, this review as a document in this particular list, right? And then I'm joining all of this review so that I will get a single paragraph, this kind of thing, right? And in this particular paragraph, you can see here, guys, we have a couple of special characters like this. That is something we are calling as a punctuations, right? So this is something we are calling as a punctuations. Okay, so let's first see how you can remove the punctuations. It's not a conditional loop, Shobit, right? Okay, so this is the one way how we can remove the punctuation, guys. And let me just tell you, this is one of the approach how we can apply different text data pre-processing part. This is not the only way. Okay, apart from that, you can adopt another approach also. So today I will show this particular approach, how you can apply this text data pre-processing steps individually. And probably in upcoming sessions, I will also show you how you can do all of these things in some other way. So for the timing, let's see how we can apply each and every part of the text data pre-processing as an individual section. Now to remove the punctuations, guys, we are using something called as a translate method for our text data. Under the translate, we have another function called as a make trans. And this is how it will take as a argument, like this is a blank, this is a blank, and then string dot punctuation. So what it will do? So this first argument, we call it as a argument X. Second argument, we call it as a argument Y. Where X and Y is nothing but these are the characters in this particular document. So this is my text data, right? This is my text data. Now what it will do? It will check each and every character X and Y, and if it will found any of the special character, it will replace by Y. So this is something what we have as a X, first one. Second one is a Y. So X is nothing but each and every character in my input data. It will check each and every character one by one. And if there is any special character, for example, let's say for this particular sentence. So first it will check for I. So this is a X. In the next time, the X will be on J. Next time, X will be on U, then S, then T, then L, O, V, E, and then I, T. After T, when it comes to this backward slash, this X, So here it will identify that this is a special character. Now, once it will identify the special character, this X will get replaced by this Y. And what is a Y? Y is nothing, right? It's a nothing. So it will just remove this special character. That means. So this is how this function works. It will go each and every character wise, and then whenever there is a special character is present, it will just remove that special character. And this is what you guys will get as the outcome. Now you can see there is no special characters present, right? So whatever explanatory sign or backward slash we have, all those things will get removed. Okay. So this is one thing. Then we study something called as a tokenization. What is a tokenization? Tokenization is nothing but each and every word of your document will be one token. So tokenization will break down your sentence into tokens, which is nothing but each and every word. So this is what we are doing with the help of NLTK library. So under the NLTK, we have a module called tokenize. Within that, we have a method called word underscore tokenize. This is what we are calling as a word tokenizer, right? And then we are applying our text data. So no punch text is the outcome of the previous step. So you can see here, whatever outcome we are getting from this, translate method, we are calling as a no punctuation text. This is the input for my word tokenizer. So word tokenizer will take input of this particular data and it will create the tokens. So here I have just printed the first 50 tokens for this data. So you can see it is one token, amazing is another token, battery is another token. So likewise, it will just break down this sentence into individual words. And each and every word will be one token, like that. Okay. Is this part is clear, guys, up to this one? How we are getting the tokens? Okay, use of token and repeat. Okay. So let me just repeat it. So this is, guys, what we got from the the first step, like how we remove the punctuation. So all of the punctuations will get removed at this particular stage. Now here we are going to apply something called as a tokenization. So what is a tokenization? Tokenization will convert your, it will convert your input text data into the tokens. What are the tokens? Tokens are nothing but each and every individual word is one token. So that means it's is one token, amazing is another token, battery is another token, last is another token. Likewise, each and every individual word will be one token. Okay. So this is what we are getting from this particular method called word tokenize. And this method is available under the module called tokenize, which is present in the NLTK library. Okay. So now you can see here I have just printed the first 50 tokens. So it is one token, amazing is another token, battery is another token, last is another token, like that. Now there is one question, guys. Why there's a need to get these tokens? Why to apply the tokenization? So if you recall, we have some other steps in the data pre-processing that is called as the stop word removal, lemmatization, like that. So to apply, these kind of steps, we need each and every individual word, right? So that's why we are getting the tokens. Now let's see how we can apply the stop word removal concept. All right. So guys, to remove the stop words, actually in the nltk.corpus module, we have something called as a stop words present in the English language. So this is the list of stop words which are in English language, we can directly download this particular list, and I'm saving this list into a variable called my stop words. And if you just see this particular list, so this list is already there in the NLTK library, right? So we have just downloaded this particular stop word list in English language. Okay. So if you see, guys, this stop word list, so in this list, we have a different stop words which are already present. So these are the stop words which we have already present in this list. All right. So this is the list of stop words which is already there in the NLTK library. Now let's suppose, let's say, guys, this is the list what we have as a list of stop words. And in the last, you can see we have a would not. This is the last word. But let's suppose we have a couple of words in our data which are the stop words, but that is not listed in this list. So what you can do, guys, you can even add a word as a stop word in this list. For example, I'm just taking one example. Let's say there is a word called the. Let's say this particular word is not there in this list, and I want to add this word in this list as a stop word. This is also we can do. And if you guys recall from the pandas data structure class, Python data structure class, so there we saw how we can append a particular element in the list. So we have a method called append, right? So this is the list, name of the list. In this list, I'm appending a particular element called the. And after that, if I see the outcome, so now you can see this element is present at the last, right? So in that way, you can even add a particular word which you think that it should be a stop word, right? And you can use this particular list for stop word removal. Now let's see how stop word will get removed. So it's very simple. Here we are applying list comprehension method. So what this particular line of code is doing, actually, it will check each and every token. It will check each and every token. So whatever tokens we get. So that's why we got this tokens. So we will, go through each and every token, all of these tokens, and we will check whether this token is present in this list or not. If the token is present in this my stop word list, that means that token is a stop word. And I will just remove those words. Rest of the words I will take in the output. So this is the idea how we can remove the stop words. And this is why we have done with the tokenization part. So this is what we are doing here, actually. We are, applying this particular concept or this loop for each and every token. If the token is not present in the stop word list, just get those tokens. So by default, if the token is present in the my stop word list, it will get removed, right? And you can see that this is what we are getting the outcome. Let me just show you by adding. Okay, let me run this one. Okay, for the timing, let's see. So like this is how we are getting. We are removing the stop words, and rest of the words we are getting as a token, right? You can even apply the lower case. So after removing the stop words, now I'm applying something called as a this process is called as a normalization. That means we are converting each and every token into a lower case. We are normalizing our input data. So we are using something called as a lower method. So it will go through each and every token in this particular list of tokens, and it will convert them into a lower case. So you can see here, let's say this Diwali token. So D is in caps. After getting the, in a lower case, now I'm getting all of the tokens in the small case, right? Like this terrific or you can say technically. So each and every one is in lowercase. Let me just show you stop word removal. So let's say, guys, here I'm adding one of the token called its. So you can see in my like tokenization output, we have a token called its. Let me add this particular token in the stop word list. Let me just show you. Let me add it like here. So it is the ITS. Like that. Okay. See here, guys. So I have added a new token called its ITS like this. Right? Now I'm going to apply the same code. So what this code will do? It will check each and every token from the output of tokenization, whether that token is present in the stop word list or not. If the token is present, it will remove that word. If the token is not present in this stop word list, it will just take those tokens as the output. Let me just run this one. Can you guys see? I don't have the first token, it's in the final output because this token is present in this my stop word list. Right? So let me just show you the outcome of the tokenization. This is what we got the output of tokenization. I have added this particular token in the my stop word list. And when I removed, the stop words, so I'm not getting that stop word, which is the its. I mean, this is how we can remove the stop words, right? And then we can convert into the lowercase that is called as a data normalization. Is that clear, guys? All of these steps? Okay, just a minute. Let me also check with YouTube, guys. Okay, guys. Cool. How to convert a word from capital to small? Okay. Special character removal code. Okay, not an issue, guys. Let me repeat it once again. Yeah, number is allowed, right? So sometimes you will get the numbers like 50, 100, something like that. That is allowed. Let me just resolve a couple of queries. Okay, so there is one query, guys. How this, the punctuation is get removed. So let's see how this particular code works. Can you see here in the make trans method, we have a two arguments, first one and second one. And in the both argument, we have a nothing. It's just a quotes. It's a nothing, right? So the first one we call it as a X. Second one is a Y. So what is this X and Y actually? X is nothing but it is each and every character present in this text data. So it will go character by character in this text data like this. So for the first instance, the X is this particular character I. Next time, the X is this T. And then the next time, the X will be this backward slash, this one. So likewise, X will move character by character for this text data. And whenever it will come across any of the special characters, it will replace this value by Y. And what is the Y? Y is nothing. It's nothing. So if I replace this backward slash with nothing, that means it will get removed. This is how this, this translate function works here to remove the punctuations. Right? Is that clear, guys? Okay, so this is one thing. Cool. And then there was another question, how I converted, these tokens into the lowercase. So here we have a method called lower. So this syntax we call as a list comprehension, right? You can also write the loop, but this is a shorter way to apply the loops. And this particular method is called as a list comprehension. What this method will do, it will check each and every token in this particular list of token, no stop tokens. So this is the no stop tokens we have. It will check each and every token for this particular list of tokens, and it will apply the lower method. So what lower method will do? It will convert each and every word into the lower case. Okay. Cool. So this is how we have applied the tokenization. And then we saw how can we remove the stop words, and then how to convert your tokens into the lower case. Now let's see the concept of stemming and lemmatization. So this is, guys, how we have a stemming part. So under the nltk.stem module, we have something called as a porter stemmer. So this is the name of the stemmer which will perform the stemming operation. So we are just, initializing this stemmer as a PS. And again, we are using the this list comprehension. What it will do, it will take each and every token from this lower word list. So this is what we have, a lower word list, right? So from this list, it will take each and every token, and it will apply this particular stemmer, porter stemmer. And let me tell you guys, this stemmer and lemmatization, not necessary you guys will get 100% correct result. Sometimes you will get some, very abnormal result also. For example, when I applied the stemmer over this particular, set of tokens, you can see here. Let me first run it. Okay, you can see here, guys. First, it applies to first token, which is the amazing. It will remove the ing. So since it is the stemmer, right? So what stemmer will do? It will just remove the suffixes or prefixes. It will remove the ing from amazing, and the rest of the word is the output, which is the amaz. But do you think that this is any word present? No, right? The actual word is the amaze, amaze. So this is the drawback of stemmer. If you see the second word, battery, so this is very abnormal result. It will replace y with I. This is how it's working here. So that means not 100% time you guys will get the correct result, right? This is something we need to observe and analyze the outcome. Okay. If you see this student's token, so it will just remove this S, and the rest of the word is the output. If you see this finally, so here it removes the ly instead of, like getting the I in place of Y, just like this battery. It removes ly, and whatever is left, that is the final outcome. Right? This is how it works. Is that clear, guys? This part? So this is what we have something called as a stemmer. Okay. And here I have showed you how you can apply the concept of tokenization using the Specie library. So like under the Specie, we need to load one module called as a N-Core WebSM, right? And then we can apply, the lemma is a method available, which we can do this, tokenization kind of thing. But anyways, this is some extra part. But yeah, up to this part, guys, clear? What is the stemming and all? Why do we take PS? Okay. So this is how we are initializing this particular method called porter stemmer. Right? If you don't want to write this line, what you can do? You can directly use porter stemmer in case of a PS. Okay. Yeah. So this is how, guys, we can apply the different data pre-processing steps over the text data. And let me recall you, one part is left, that is the lemmatization. I will come back to that part, okay? So is that clear, guys, up to this part? Let me check with YouTube, guys, also. Access to LMS. So, guys, Amar has done a couple of KTs for the LMS part, right? Still, if you have any issue to access, to get access for LMS portal or material kind of thing, you can ask to Amar at the end of session, right? But that part is done multiple times. Okay, so let me share my screen once again. Cool. So lemmatization part is left, guys. I will come back to that part in some time. But before that, let's see the other block, what we have something called as a vectorization, right? So let me just recall you. You have an input data, which is an input text data actually. Input text data. Over this data, we apply the text data pre-processing to clean our input text data. And once we get the clean data, so what are the things are there in this text data pre-processing? So like removing the stop words, removing the punctuations. If the URL is present, you can remove the URL also. Or we have a tokenization, we have a stemming, lemmatization, all of those things are there. And once you get the clean text data, then apply something called as a vectorization. What vectorization will do? It will convert your clean text data into the vector representation or equivalent numerical representation form. Now let's understand what are the different methods we can choose to apply the vectorization part. Okay, so actually there are a couple of methods available which you can select to convert your clean text data into the equivalent vector representation form. And let me just show you, like, okay, so it looks like this, guys. So let's say you have a document like this one. So it will just convert this document into this kind of a matrix form. This is something we call as a vector space representation, or the method is called as a vectorization. Now in the vectorization, guys, there are two terminologies are there. There is something called as a TDM matrix and DTM matrix. So let's first understand what is the TDM and what is the DTM. So TDM is nothing but, guys, let me use this page. Okay. So let's first understand what is the TDM matrix. So it is the matrix kind of a representation like this, right? Where we have a different rows and columns. And let's say this is a column 1, column 2, column 3, like that we have different columns. So DTM matrix is nothing but, guys, what it will do, let's say in your corpus you have a 4 documents, or let's say you have a 5 documents, D1, D2, D3, D4 and D5. Let's say you have a 5 documents, and what is a document? Each and every review is called as a one document, right? Now, what TDM matrix will do? It will, after data pre-processing, it will take all the unique tokens. I'm repeating it again. After applying the text data pre-processing part, whatever clean text data you have, from there, it will take all the unique tokens and it will place each and every unique token on the row side. So the first row is a token 1, second row is a second token, third row will be the third token, like that. So it will take from all the documents, it will take each and every unique token, and those unique tokens will be on the row side. And over the column, we have a document number. So document 1, document 2, document 3, document 4, and document 5. So this particular arrangement, where on the row side, we have the unique tokens, on the column side, we have a document number. This kind of a matrix is called as a term document matrix. TDM stands for the term document matrix, right? Because on the row side, we have the term. Then over the column side, we have a document. That's why term document matrix TDM. And why we are taking the row first? So if you see, for matrix, how we decide the dimension, M cross N. So M is the number of rows, right? So row will be the first, and then number of columns. So based upon that, first check the row. So if the over the row side, if you have a unique tokens, so it will be term document matrix. And if you have a inverse arrangement, let's suppose on the row side, you have a document number. Over the column side, you have a unique tokens. That is something called as a document term matrix, DTM. So this is how we have these terminologies. Is this part is clear, guys? Yes, Shobit, I'm coming to that part. Okay, if this part is not clear, let me just show you through an example. So let's see this particular thing. So let's suppose, guys, this is something what we have a document, this particular thing as a document. So what we are studying here, we are studying the vectorization. And the output of vectorization will be a matrix where you have the numerical representation of your text data. Right? Numerical representation means you have some numerical values that will be equivalent to your text data. Now this matrix, we have two terms of this matrix. Either the matrix will be TDM matrix, term document matrix, or DTM matrix, document term matrix. So how would we decide the matrix will be a DTM or TDM? So it simply, if your unique tokens will be on the row side. So if you see, we have a unique tokens over the row side, right? In this particular example. And over the column, we have a document number 1, 2, 3, 4, 5. So if this is the arrangement, then the matrix will be term document matrix because the terms or tokens will be on row side. If you just inverse this case, that means on the row side, if you have a document 1, document 2, document 3, and over the column side, you have a term 1, that means the first token, token 2, token 3, like that. This is something called as a DTM, document term matrix, because on the row side, we have a documents. Right? Don't concentrate over these numbers 1, 2, 3, 4, whatever number is present. Don't concentrate this number. This is some example. So, like this is how it is decided by whatever technique you guys are choosing. So based upon that, the number will get populated here, right? But the arrangement will be like this. Okay. Guys, attendance form is there over the chat box. You can mark your attendance, right? Now let's see what are the different methods how you can convert your document into this kind of a matrix representation. Okay. So one of the method, guys, we have something called as a binary weight. It is also called as a one-hot encoding or binary weight. Let's see, guys, how this method will be useful to transform your text data into the numerical representation form. All right. So for example, let's say we have three documents, document 1, document 2, and document 3. In the document 1, we have a input data like text mining is to identify useful information. This is the first document. Second document, we have a useful information is mined from text. In the third document, the apple is delicious. So like that, we have these three documents, right? For the time being, let's ignore the text data pre-processing part and only focus over this binary weight method. How we can transform this text data into the numerical representation. So in total, we have three documents. And how the representation will look like. So here, if you see, guys, on the row side, we have a document number 1, document number 2, document number 3. On the column side, we have unique tokens. So text is one token, which is this one. Information is another token. Identity is another token. Mining is another token. Mined is another token. Is another token. Useful another token. To another token. From, where we are from, from is another token. Apple is another token. Delicious is another token. So we are taking unique tokens from this corpus, right? Yes, correct. So if you see, guys, so here what arrangement we have? On the row side, we have the documents. On the column side, we have the unique tokens. Since we have a document on the row side, so this matrix will be called as a document term matrix, DTM. Now let's understand how the values will get populated here. So guys, this is the binary weight method. In the binary weight method, we either have a value 0 or 1. And how we decide? So if the token is present in the document, we will populate the value 1. If the token is not present in the document, we will populate the value 0. Let's see. Let's go column by column. So the first token is a text. Whether this token is present in the document 1? Yes, present, right? Here we have this token text. So just populate the value 1. Check for the second token, second document. Whether this particular token is present in the document 2? Yes, it is present. Populate 1. Whether this token is present in the document 3? No, 0. So this is how values will get populated. Let's check for another token. Let's say delicious. Whether this token is present in the document 1? No, the value will be 0. Whether it is present in the document 2? No, the value will 0. In document 3, yes, present, the value will be 1. So this is how the values will get populated in case of the binary weight method. Right? So this is something, we have a binary weight method to get the vector representation of your input text data. Is that clear, guys, this part? Any doubt, anyone? Cool. So this is one method. Let me just show you a couple of other methods, guys. So apart from binary weight, we have another method called as a bag of word approach. So this one is also called as a count vectorizer, right? Bag of word or count vectorizer. So in case of a bag of word or count vectorizer, what we do? Let me just explain you from here also only. So in the case of guys, so this is the first method, binary weights. Let's see the second method, what is something called as a count vectorizer or bag of word. Count vectorizer or bag of word. So in case of a count vectorizer, guys, instead of populating the value 0 or 1 based upon the token is present or not, we will populate the value based upon the token frequency. That means the number of times a token present in a particular document. For example, let's take the same example, and let me just tune this particular text data like that. Text mining is to identify useful information from text. Let's say this is what we have a document 1. Useful information is mined from text. Okay. Okay, let's take it like this. Apple is delicious. Apple is delicious. Okay, just take it like this. Okay, so let's suppose, guys, this is what we have a text data, and we are applying the count vectorizer. Count vectorizer. So as I told you, what count vectorizer will do, it will check the frequency of a particular token. So what is the first token? We have a text, and now it will check how many number of times this particular token appears in each and every document. So if you see in the document 1, the text appears 1 times and then 2 times. So here we'll populate the value 2. So this is something what we have a count vectorizer, right? So based upon the frequency of the token, we will populate the value. Okay. And then we have a third kind of a vectorizer, which is called as a EFIDF vectorizer. So let me just check. Okay. Need of the vectorization. Amol, this is what we have discussed multiple times. So why we are doing the vectorization? Basically to get the numerical representation of our text data. Because until unless you will get the numerical representation, you can't apply any of the statistical techniques or methods or any of the models. So to apply any of the computational method or statistical technique, we need to have some numerical data. Right? So this is why we are applying the vectorization to transform our text data into the numerical representation form. Okay. Now the third approach is the TF-IDF vectorizer. So like this is another approach. So at the backend, it is using some kind of a formula like this. And this formula will calculate the weightage of each and every word. Weightage in terms of the how a particular word is important. So for that, at the backend, it is using this kind of a formula. And based upon this formula, it will come out with certain kind of a weight value, and that is something we call as a like vector representation for each and every token. For example, let's say we have these 3 documents. We are reading about natural language processing here. Natural language processing, making computer comprehend language data. The field of natural language processing is evolving every day. Let's say we have a 3 document, and then let's suppose these are the tokens what we have. Now for each and every token, it will apply these formulas, right? So it will calculate something called as a TF, right? And then it will calculate IDF part. So TF stands for term frequency. So this is the frequency of each and every token. And then it will calculate IDF part, which is the inverse document frequency. So IDF stands for inverse document frequency, right? So for each and every token, it will calculate the inverse document frequency. and then it will just multiply these two results. So that is the final weight for each and every token. And IDF part, this inverse document frequency part, it will tell you how important a particular token is. So here we have a frequency of the token as well as how important a particular token is. So both information is present in this particular TF-IDF weight. And this is how, this is a sample example. So this is how you will get values for each and every token. Now, instead of, frequency or 0 or 1 kind of a structure, now we have these kind of values. So this is something what we have as a TF-IDF vectorizer. And these are the different methods what we have perform the vectorization. So we have discussed 3 methods. One is the binary weight, where the value will either be 0 or 1 based upon whether the token is absent or not, right? Then we have a count vectorizer or bag of words. Bag of words or count vectorizer. So based upon count vectorizer, we'll be having the value as a frequency of each and every token. How many number of times a particular token appears in the document. And then the third method is a TF-IDF vectorizer. So it will, at the backend, it will do certain kind of a computation, and based upon that, it will come out with the weight value. So I mean, all of this approach will convert your text data into some kind of a numerical representation in form of the matrix. Right? Is that clear, guys? The vectorization part? Okay, cool, great. So this is what I need to discuss with you guys in today's session. And tomorrow I will show you the lemmatization part hands-on, as well as how you can apply these techniques, using over the text data to get the vector representation. And along with that, I will also show you some, more concepts. Right? I hope you guys understood how you can deal with the text data, right? Shobhit, probably these PPTs and the dataset is present over the LMS, but if not, definitely you guys will get by tomorrow. Okay. Okay, guys. Great. So, any questions, guys? Anyone? Okay, there is one question. Repeat the technique names. So, guys, I have discussed 3 techniques. One is a binary weight, then count vectorizer or bag of word approach, and then the third one is a TF-IDF, term frequency, inverse document frequency. Right? What is feature? There is one question, guys. What is a feature? So, actually, here in terms of the text data preprocessing, this particular vectorization part is also called as a feature, getting the features. Or if you recall the yesterday session where we were dealing with the numerical data. So in that case, the meaning of the feature is basically the columns, right? Okay, so ChatGPT part, I will start after this, the basics of the NLP segment. Ashutosh, there is one question, guys. Why we convert text to numeric? So this is what I explained multiple times. After all, we need to apply some kind of a statistical techniques, right? So, okay, so can I apply, let's say I have a very basic calculation, like I want to multiply my data by 2. So can I multiply a text data by 2? No, right? So I need some kind of a numerical representation for that. That's why we need to convert the text data into numerical form. Don't worry, Kritika. Tomorrow I will show you the implementation part. Right? Again, I will discuss this part, vectorization part. Divya, it's a bag, BAG. Yes, Paras, the recordings will be available for the lifetime. You can directly apply the lemmatization, right? Okay, great. So I understand, guys, these terms are very new to you guys, right? Like bag of word, count vectorizer, TF, IDF, all of those things. Tomorrow, I will again explain these things, but through hands-on, right? So that you can see how we can convert the text data into the numerical representation, right? So don't worry about it. Guys, attendance link is there in the chat box. So I will request Amar, please post the attendance link once again over the chat box, right? Cool. So if you don't have any question for me, so over to Amar. If you guys have any question related to LMS part, how you can access the things, you can ask with the Amar.
Yeah, sure. Thank you, Vikas. Yes, guys, if you have any query or question for me, please let me know. And coming to the attendance part, I just shared the attendance link once again in the chat box over Zoom and YouTube as well. So please mark your attendance. Sir, how to open LMS? Sir, my previous result. So I'm gonna drop any email to EDL team. Can we leave? Yes, guys. If you don't have any query or question, you can leave. Okay, thank you. Sir, I have only giving a feedback, so I will mark absence or attendance form is a feedback form only, okay? His PPT is not available on the LMS. We already shared with the team. I will check, and if it's not there, by tomorrow it will be there. Okay. Sir, I completed my Python SQL class, but sir, drop an email to edl at the textlar. All right, sir. So those who are asking me how to access the LMS, so you can go through the yesterday's recording, day one recording or is day two recording. Day one recording, first half an hour. Day two recording, last half an hour. Okay. सर डे 3 वाला मटेरियल अपलोड नहीं है LMS पर. Okay, we'll check. How many are you there? Those who are here for first time, be like you are attending a first session of this training program. Can you please raise your hand or just type Y in the chat box? I got 1, 2, 3, 4, 5, 6. Okay. So those who are new here and facing a difficulty to access the LMS, I'm requesting them drop an email to edl@xlar.com. Our team will check your account status and they will let you know. For your reference purpose, I'm sharing that email ID in the chat box. Okay. So please note it down. edl@xlr, not Excel, EXCELR, xlr.com. Okay, there are 3-4 participants over YouTube as well. Can we get the link to LMS? So that what I just explained that. So those who are new here, drop an email to EDL team. They will check on the same. Sir, how? Hey, I just explained that, no? Sir, will our attendance percent will be visible in LMS? No, not at all. Attendance link, please. It's closed, Naneshwari. You're not able to fill attendance now. I'm kidding. Don't worry, I'm sharing that. Just allow me a couple of seconds. Guys, any another question? YouTube participant, are you there? If yes, let me know. Filling the form once is enough in attendance link, sir. Filling the form once in a day, it's sufficient. Every day you have to fill that form. Sir, I have done attendance for me. And why you are doing attendance for two persons simultaneously? Because of my sister. So your sister is attending the session with you. Sir, you have any offline courses in India? Yes, yeah, we are from India only, na. So coming to the India, so we have office in Mumbai. We have two locations, Andheri and Thane. Then in Pune we have two locations. It's Viman Nagar and Barnet. Then again in Hyderabad, Cyber Tower, BTM Layout, Bangalore. Then Jepok, Chennai. Okay, Mumbai. Yes, we have two offices in the Mumbai. Yes, guys, you can leave if you don't have any query question. You can leave, sir. I want to do a data visualization. So Sridharan, I'm sharing my contact number with you. So you can drop me a WhatsApp message. Probably I will help you on the more details. I will share the complete brochure and all our data with you. Yeah, I shared that with you. Yes, I attended but didn't post the attendance. You have to post the attendance br@05 over the YouTube. If not, I am sharing it once again. Please mark your attendance. It's important. Do we get certificate after the end of the session? Not after the end of the session, but after completion of this training program, you will get after 7-8 working days, you will receive that. Sir, will get the assignment? Yes, definitely. You will get the assignment over the LMS portal, but it will be there for your practice purpose. No need to submit that assignment anywhere. Yes, sir. I got a call from XLR team, but I didn't leave the call because I am in the class. So you call back, Yamuna? No, I'm asking you called back or not. Attendance link sent once again, please. Yeah, sure. I'm sharing that. Guys, 2 more minutes. Any query, any question, let me know. We'll wind up at 9 o'clock. How to mark the attendance? I'm newly joined today. So I just shared the attendance link in the chat box. You have to click on that. It will take you to the Google form. You have to submit your personal details like email ID, mobile number, name, your stream branch. And after that, you have to submit your feedback. Done. That's the way to submit your attendance. Sir, I got an confirmation email and XLR team, sir, regarding I called, but they didn't leave. So, Yamuna, can I know the name of that person? Okay, yeah. Yeah, Sridharan, you can contact me. We'll discuss more on that. Mm-hmm. Oh, sir, I'm getting error while importing the dataset in the Jupyter notebook. Can you please explain it in tomorrow's class, sir? So you can ask this question on tomorrow's class. So sir will help you on this. Okay. When we click on download to download document, it's element showing some code, sir. What could be the problem, sir? Code means it's code only, na? It's not a problem. It's a solution. Ma'am, you does not drop a contact details. Praveen, why you require the contact details? सर लीव हो सकते हैं क्या अब मीटिंग से? यस हो सकते हो, बट सर इज नॉट सीइंग माय मैसेजेस सर. I think you are sharing with me, na? You have to share with sir. So sir is to take a break between like after half an hour. If there is any query or question, you can put your query at that time. Definitely sir will take it up. Sir, I'm practicing to solve the Power BI dashboard. Yeah, definitely. As Excel solutions, we have a 6 months of training program on a data analyst. In that, we used to cover many more things like advanced Excel, Power BI, Tableau, then MySQL, then basics of R, Python, statistic, and it used to come under the placement and internship as well. Okay, sir. Thank you so much. You're welcome. Sir, please once again say how the attendance will take. Attendance, I'm sharing the attendance link in the chat box. You have to click on that link. It will take you through the any of the web browser, your default web browser. You are able to see one Google form. There you have to mention your details, submit that form, your attendance is marked. But most important thing, that link will only open between 8:30 to 9:30 p.m. Sir, today is my first class. Can you brief me a little bit? So I'm suggesting you as you join over the YouTube, you can go through the day 1 and day 2 recording. You will get a more idea about the training program. What we are done. Okay. Can you please share the link, sir? Which link are you looking for? Sir, repeat attendance will not submit. So Sumona, from one system, it's not going to work. You said, ma'am, for more questions, you can contact on WhatsApp. So Praveen, drop an email to edl@texla.com, or if you have more question, definitely I am sharing the contact number for query and question. Don't be like, good morning, sir. Good night, sir. How are you, sir? Where are you, sir? Okay. Any another things, guys? I hope you're enjoying the session. Yes, yes. Only 1 yes out of 180 participant. No, I'm not going to read you a question. I want response. You are enjoying the session or not? Shall we leave now? Yes.